we're going to talk about ways of determining the validity of categorical syllogisms. Why should we care? What is it for an argument to be valid?
Having a form where the premises make or if the premises are true, the conclusion is true.
Yeah, I would prefer to say first, having a form where the premises guarantee the conclusion. Now, you gave me a good test for when it's valid, but the downside with that test is it sort of makes people think that the premises in fact have to be true. But they don't. You can have a valid argument with obviously false premises, like if the moon is made of green cheese, then Elvis is alive. The moon is made of green cheese, therefore Elvis is alive. That's still a valid argument, because if the premises were true, then the conclusion would have to be true, even though they are in fact false. Okay, so validity is when is a property of arguments. In fact, I'm going to redraw this little table that I had here. I'm going to call this column things. Not very informative, but best I can do. And then I'm going to call the second column relevant properties. That is, properties applicable to the things in the first column. And I'm going to list the things in sort of increasing order of size. Well, they're not really things that have size, but you'll see what I mean. The first one is terms, like S, P, and M. Then I'm going to have propositions, which are sort of larger in an abstract sense than terms because they contain terms. A categorical proposition has two terms in it. And then finally, propositions make up arguments. So each of the lower things has the thing above it in it. Okay. Now, propositions we have talked about perhaps the most. What is the defining feature of propositions? What properties do they have?
Truth value.
Truth value. So they are either true or false. So the relevant property that we care about with propositions is the truth value. And incidentally, each of these properties is either you have it or you don't. It's black or white. So truth value, you're either true or you're false. There's no gray area. Arguments. Now the property of arguments that we care about is validity. And again, like truth value, it is either you have it or you don't. If you're not a valid argument, you are an invalid argument. There's no degrees. And then the last property that we're going to talk about, and I'm going to qualify this in a second, is distribution. Because we're about to talk about rules for testing validity, and we're going to need to know what distribution is. Now my qualifier is terms in general do not have this property. So for example, I might say frogs. Now frogs is not a proposition. How can I tell that frogs is not a proposition? It doesn't have truth value. Frogs, true or false, right? It doesn't even make sense. Because to be a proposition, it would have to say something about something. And frogs doesn't do that. It's just a something. Okay, so you can have a term, because frogs is a term, because a term is just a group of things. Now, is frogs distributed? Well, no, that question doesn't make sense either. Frogs just by itself is neither distributed nor undistributed. But when a term is in the context of a categorical proposition, I'm going to be lazy and abbreviate that as CP, then a term is either distributed or not distributed. And we'll see how that works in a second. But I just want to say a little bit about keeping these properties distinct. No proposition is distributed. No term has truth value, as we just saw. Frogs is neither true or false. But the ones that people often get confused is they sometimes say that arguments are true or false. No. Arguments are not true or false. Because we think of arguments by their form. This is an argument. Is it true or false? Well, first of all, you're talking about three things, three propositions. And even if you could tell the truth value, well, one might be true and the other one might be false. So you can't say the argument as a whole is true or false. But even more strongly than that, you can't even tell the truth value of these propositions, because it says some MRP. And suppose, now we happen to know what they stand for, but if you didn't, it wouldn't affect it. You can work out whether or not this argument is valid just as is. It doesn't matter what it's talking about. This is the logical form, and that determines whether or not it's valid. So, arguments are composed of propositions. Propositions have truth value. They can be true or false. So you can have an argument made of true propositions, you can have an argument made of false propositions. But the argument itself is neither true nor false. Another mistake that I've already talked about is people sometimes use the word valid to apply to individual claims. Like they say, oh, you made a valid point. Well, as I said, you don't say that in this class. Validity is simply a property of arguments. And the reason why it can't be a property of individual propositions is because it's a property to do with the relationship amongst propositions. So whether or not an argument is valid depends on whether or not one proposition or one set of propositions supports another one. And that can't happen if you just have a single proposition. So don't get the properties mixed up. All right, little speech over. Let's talk about distribution. Why do we need to talk about distribution? Well, the main reason we need to talk about distribution is because we need to know what it is to be able to tell when an argument is valid. Open your textbooks to page 249. There we have a nice little box. The rules for testing validity. Now, these rules only apply to categorical syllogisms, which is a little restricted because any argument can either be valid or invalid. Any argument you can think of, an argument with one premise, an argument with 1,000 premises can be valid or invalid. And these rules only work for a very specific kind of argument, categorical syllogisms. You know, that's kind of a small subset of all possible arguments. So why do we care? Well, the answer is kind of historical. As I said last time, the Greeks were kind of obsessed with syllogisms and thought just about every argument could be expressed as a syllogism, and they thought just about every proposition could be expressed as a categorical proposition. So they thought that this covered a huge range of arguments. And in fact, there are an awful lot of arguments that fit into this form. I opened your book to the right page for you. So it's worth knowing. But you also need to remember that these rules of validity don't work for every single argument. All right. So these are rules that we can apply to work out whether or not an argument is valid. Why do we care whether or not an argument is valid? What's the answer? Even if you don't, in fact, care, tell me why you should.
Because if it's not valid, then it's not an argument.
Well, it is an argument, it's just a bad argument, right? Yes. In other words, what is the point of an argument? To prove something, that's right. You give arguments when it's not enough simply to state a claim. You know, so for example, it would be nice, particularly if you're the defendant, if all you had to do is stand up and say, I'm innocent, right? I rest my case, Your Honor. When will I be walking out of here? That would be good, but of course your innocence or guilt is open to question. And when something is controversial or subject of dispute, then nobody's going to just believe you if you say, no, let me say that again louder. I'm innocent, right? That's not good enough. You need to prove it. And that's what arguments are supposed to do. But of course you can have good arguments and bad arguments. A bad argument in the context of deductive logic is one where the premises fail to guarantee the conclusion. Now this can be obvious. This can be obvious as, for example, when the premises aren't even relevant to the conclusion. But we can, for example, when I was talking about the 3 totally unconnected categorical propositions last time, like all oranges are fruit, all chihuahuas are dogs, therefore all trucks are vehicles, you know, then there's no semblance of relationship amongst those. But it can be less obvious. It can be less obvious. They can be talking about the same thing, but still fail to be logically constructed in the right way. So, and sometimes you can say, there's something fishy going on here, but I'm not quite sure what, or sometimes you can just be fooled. So it is enormously important to be able to have a hard and fast test for whether or not an argument is valid. And that's what these rules do for categorical syllogisms. So, notice that the first 2 of them talk about distribution, which is why we need to explain what it is. So get ready, because here it comes. A term in a categorical proposition, because as I said, the term by itself is neither distributed or not, but a term in a categorical proposition is distributed, and I'm going to use a slightly jargony abbreviation that you come across when you all become philosophy majors, as no doubt you will come across this, this terminology, IFF. It is an abbreviation for if and only if. Now you might say, well, what's the difference between that and if? Well, you'll find out in the next chapter we get to. But for now, that's what that means, if and only if. A term in a categorical proposition is distributed if and only if the categorical proposition tells us something. This is kind of a vague definition, but it works, so don't knock it. If it ain't broke, don't break it. Tells us something about every member of the term in question. Okay, that's the definition. Now let's see if we can apply it in practice. Let's look at all the terms in all of the 4 basic types of categorical propositions. Remind me what those are. What is an A-type? All SRP. Everybody. An E-type?
No SRP.
No SRP. An I-type?
Some SRP.
Some SRP. An O-type? Some S or not P. Okay. Now, each of these has 2 terms in it. So we have 8. Good math there. We have 8 things to settle. Let's start with this. Is this term S distributed here? Who says yes? Who has no idea? Okay, well, let's look at the definition. We're asking whether or not S is distributed in this context, in the context of all SRP. How do we answer that? Well, a term in a categorical proposition is distributed if the categorical proposition, which in this case is an A-type, tells us something about every member of that term. So let's give an example. All whales are mammals. If I tell you that, do you know something about every whale?
Yeah.
Yes.
So that means that this is distributed. Easy peasy, right? Okay, so the subject term of an A-type is distributed. Why? Because you're talking about all of them. Hence the word all. Okay? How about the subject term? Let's do all the subject terms first. How about the subject term of an E-type? No cats are dogs. If I tell you that, do you know something about every single cat?
They're not dogs.
Yes, you can say with confidence to every cat, you are not a dog. I know that for a fact. Yes, so S is distributed in an E-type. What about in an I-type? If I tell you some cats are cute, do you know something about every cat?
No.
No. Why not? Yeah, because we're just talking about some. Same for some cats are not cute. Again, you're just talking about some. So, we've finished with all the subject terms. Can we come up with a general rule for when the subject term, of a categorical proposition is distributed if and only if the categorical proposition is universal. That's right. So to work out whether or not the subject of a categorical proposition is distributed, you look at the quantity. Universal, yes. Particular, no. Universal, and not otherwise. Well, I don't need to say that because I've said if and only if. Okay. Now, let's see if we can come up with a rule for the predicate term. All right. All whales are mammals. If there's one thing you learn in this class, it will be that. All whales are mammals. Do you now know something about every mammal?
No.
No. So that tells us that the predicate term in an A-type is not distributed. So I'm not going to circle it. Let's give it a little X. No cats are dogs. Do you now know something about every dog?
Yes.
Yes, you can say to every dog, I know you are not a cat. So this is distributed. Okay? Some cats are cute things. If I tell you that, do you know something about all cute things?
No.
No, you don't. So notice that both terms are distributed in an E-type and neither term is distributed in an I-type. Fascinating stuff. All right, what about the predicate of an O-type? Some cats are not cute. What do you think? Do you know something about all cute things? Well, you might say no, but before you say that, consider this. Let's remind ourselves of the Venn diagram for O-types. Shading or putting an X? Why? So what does the X represent? Something. At least one thing. Let's say one thing. And where do I put my X? If some S are not P. I put it in region 1. Because it is in S, because it's some S, but it's not in P. S is region 1 and 2, but it's outside of P, so it must be here. Okay, so we're talking about cats and cute things. Let's say this X represents Eunice. Okay, because Eunice was a cat I had who was not cute. She had redeeming qualities, but cuteness was not one of them. All right. We do know something about all cute things. What do we know about all cute things?
Eunice is not a member.
They are not Eunice. I can say of every cute thing, I know that you are not Eunice. Yes. So that tells us that in an O-type, P is distributed because we know something about every single member of it. Okay? Yes?
So, do you mean it would be like no PRS?
What's that?
Does this mean no PRS?
That doesn't follow logically, no. That's worth, actually, yeah, I didn't say that about Venn diagrams. If there is nothing in a region, as there is, so region, what does region have, region 3 have in it? It doesn't have shading and it doesn't have an X. That means we don't know anything about that region. We don't know that it's empty. We only know that it's empty if it's shaded. But if there's nothing there, we don't know. It's like a blank area of a map. Here be dragons, maybe. We don't know. Okay? We don't know anything about it. So never assume that this shows that there's nothing there. Okay? So this doesn't tell us that this does not follow from this. Just because you know that there's something there doesn't mean that you know that there's nothing there. That doesn't follow. Does that answer your question? Okay. All right. So distribution. Now that we know the rules of distribution, oh, let me finish the rule for the predicate term of a categorical proposition is determined if and only if what? The categorical proposition is negative. So, quantity tells you whether or not the subject term is distributed. If it's universal, yes. If it's particular, no. Quality tells you if the predicate is distributed. If it's affirmative, the predicate is not distributed. If it's negative, the predicate is distributed. So, universal negative means both the subject and the predicate is distributed. Particular means the subject is not. Affirmative means the predicate is not. So particular, affirmative, neither of them. Okay? Now, why did we have to learn this? To help us with the rules of validity. Let's look at the rules of validity. Rule number 1 on page 249. The middle term must be distributed in at least one premise for an argument to be valid. Now notice, how many possible categorical syllogisms are there? I asked you, it's a simple math problem.
256.
256. How did you work that out?
Fourth.
Yes, because there's 4 elements, 3 letters and a number, and each of these, there are 4 possibilities. A, E, I, O, A, E, I, O, A, E, I, O, and 1, 2, 3, 4. So it's 4 times 4 times 4 times 4, which equals 256. That's how many possible categorical syllogisms there are, from A1 to O4. 256. In the book, it tells you that how many are valid? I can't remember, but it's either 24 or 16. It's something fairly small. A fairly small minority of them are valid. So that tells you being valid is an exclusive club. How do you enter the club? By passing every single one of these rules. Passing one of these rules is not good enough. Passing 2 of these rules is not good enough. Passing 3 is not good enough. You have to pass all 4. Okay? All right then. Let's check this one. What type is this again? Give me the abbreviated type. I3. Right? Okay, we are about to find out if this form is a valid form. If it is, then any argument that has this form is going to be valid, no matter whether it's talking about whales, or dogs, or trucks, or Ebola, seeing as that's on our mind at the moment. Nobody else has got it in America so far, have they? Just the one guy? You heard about that, right?
Better.
What's that?
The news I read recently said he's feeling better.
Oh good, because I heard he was critical when I was driving to work this morning.
Oh, that's no good.
No, but that's because they didn't recognize it was Ebola till he was in pretty bad shape. All right. It doesn't matter what this is about. It doesn't matter what the content. If it has this form, well, we're about to find out if that form is valid or not. Rule number 1. the middle term must be distributed in at least one premise. Let's look at the major premise. Is the middle term distributed in this premise? Yes or no? Yes or no? No. How can we tell? Where is the middle term? Is it the subject or the predicate? Subject. So the rule for the subject is we check whether or not it's universal. Is it universal? No. So that means the middle term is not distributed. We're just talking about some of them, not all of them. Yeah? Does everybody see that? Okay, does that mean this fails rule 1? No, it doesn't, because rule 1 says it must be distributed in at least one premise. Just because it fails in this one, it's got another chance. So let's look at the minor premise. Here is the middle term. Is it distributed in this premise?
Yes.
Yes, because it's the subject again, but this time it's the subject of a universal. So it is distributed. Does this pass rule 1?
Yes.
Yes, it does. So far, so good for IAI3. But it's still got 3 rules to go. Rule number 2. Before I go any further though, you can just memorize these rules. You probably will memorize these rules, I hope, because they're not going to be given to you on the midterm. And without knowing why these rules. But I'm going to give a shot at explaining why this is a rule of validity. Why you have to meet this condition to be a valid argument. And the best way I can think to do that is to give you an example of an argument that fails this. III3. Let's see. Is that right? Yes. What would that look like? Unpack that for me. First premise. Some SRP. That wouldn't be a premise. That would be the that's the conclusion.
Or, sorry, so
Yes, that you've given me the conclusion.
Some PRM.
some PRM. Some MRP.
Some MRP. Remember, the hair clumps in the middle. So number 3, and this represents what? The M's. So the M's are going to be first. Some MRP, because it's the first major premise. So this is some MRS. Okay. Now actually, you could have known that this argument fails rule number 1 just by the first 2 letters. How could you have known, just by the first 2 letters, that this argument fails rule number 1?
It's not universal, and it's not negative.
Yeah, because what do we know about I-types? Not their particular affirmative, so
They distribute nothing.
neither term is distributed. So you don't even have to know this. This tells you the position of the middle terms, but you don't even have to know that because you know that how many terms are distributed in the premises?
0.
Out of the 4 possible? None of them. So you know the middle term is not going to be distributed. Wherever it is, it's not going to be distributed. So this is going to fail rule number 1. Does that make sense? Okay. So this is obviously invalid because it fails rule number 1. What kind of argument would be of this form? Let me try and come up with something. Some fast thing, well actually I'm going to change it to 2 because it doesn't actually matter. Let's say some cars are fast. That's true, right? Some horses are fast. What does this say?
Some horses are cars.
Some horses are cars. Why does that not follow from the premises? Because after all, I'm telling you 2 kinds of things that are fast. Why isn't it the case that some of them are each other?
Membership in fast things don't make them equivalent.
Yes, because suppose this is fast things. Over here would be the fast cars, right? Suppose I clump together all the fast cars. There they are. Where are the fast horses?
Somewhere else inside.
Over here. What's the problem?
Didn't mean.
They don't overlap. Yes, which of course they would have to overlap for this to be true. Now, why does this illustrate that we need rule number one? Because we need one of the premises. What's the middle term? Fast things. We need one of the premises to be talking about all fast things. Because if both the premises are just talking about some of the middle term, it might be a different sum in this case. And remember what the point of the middle term is. Where does the middle term not show up in a categorical syllogism?
In the conclusion.
In the conclusion. So, but what we care about is the conclusion. So what's the importance of the middle term if it doesn't even show up in the conclusion?
It's got to connect the two premises.
Exactly. It's the link. The conclusion tells you, makes a claim that there's a connection between the subject and predicate. But one premise just talks about the predicate. So that can't support a connection between the subject and the predicate. And the other premise just talks about the subject. So again, by themselves, neither of these will support the conclusion. How is it when you put them together that they do? Well, it has to be that the middle term provides the connection that you then talk about in the conclusion. But it can only provide the connection if one of the premises talks about the whole set of the middle term. Okay, that's my best shot. If you didn't get that, it doesn't matter too much. You can just memorize the rule. But I'm trying to explain the point of the rule. Why it is that the middle term has to be distributed for the argument to be valid. It's because the middle term needs to provide a connection between the subject and predicate. And it can only do that if at least one of the premises is talking about all members of it. All right. Rule number 2, also to do with distribution. If a term is distributed in the conclusion, it must be distributed in the premise in which it occurs. Now, suppose, actually, we were talking about III. I'm going to tell you, I'm thinking of a categorical syllogism, and all I'm going to tell you is the third letter. Do you know whether or not this argument passes rule number 2? Actually, you do. Does it pass it, yes or no?
No.
Alternatively, yes. This argument, whatever I fill in the blanks, will pass rule number 2. Why?
Oh, because the terms aren't distributed in a sum SRP and an I. So
Yes, because what do we know about I types? Neither term is distributed. And what have I given you? One of the premises or the conclusion?
The conclusion.
I've given you the conclusion. What do you know about both terms in the conclusion, if it's an I type? They're not distributed. So this means it automatically passes rule number 2. Why?
Because 2 doesn't apply to it. The terms aren't distributed in the conclusion, so it can't act on this rule.
Right. The conclusion just says if a term is distributed in the conclusion, then it must be distributed in the premise. But if the terms are not distributed, it doesn't matter. Okay? So you only care about this rule about the terms that are distributed in the conclusion. Okay. Now I will try and explain the point of this rule. Remember the argument about chihuahuas. I just gave you the premises. I said all chihuahuas are dogs, all dogs are mammals. And you were able to give me the conclusion, which is what? Why is it you were able to know that? I didn't tell you the conclusion. How could you work it out? Because you're clever. But what were you going on?
The middle term.
Oh, don't worry about middle terms. Just tell me in terms of, because you could have done that before the start of the class, right? How do you know?
Because they're dogs and dogs are mammals. It's just kind of obvious.
It's obvious. In other words, you're not telling me anything new. When you give me the conclusion, you're telling me something that's already there in the premises. I've given you that information by giving you the premises, right? So you're just making explicit information that is contained in the premises that I've stated, right? That's what a valid argument does. In a valid argument, The information in the conclusion is already there in the premises. You're just making clear what is there. So you're not adding anything new. You're just saying things that are already in the premises. Okay, and that's why the premises can guarantee the conclusion, because the premises contain the conclusion. So if the premises are true, the conclusion is already true because it's information in the premises. Does that make sense? Okay. That explains rule number 2, because rule number 2 says if a term is distributed in the conclusion, well, that's information. That means the conclusion is saying something about every member of that term. But if that's information in the conclusion, it has to be already there in the premises, because in a valid argument, the information in the conclusion is already in the premises. If, on the other hand, something is said in the conclusion that is not in the premises, then you're saying things that you're not allowed to say. You're going beyond the information in the premises, and you've got an invalid argument. Now, some invalid arguments are useful, like inductive arguments that make generalizations. So, like I said, the example I always use, premise, 8 out of 10 dentists prefer this toothpaste. Conclusion, my dentist will prefer this toothpaste. Does that premise guarantee that conclusion?
No.
No, but it does make it more likely. So that is not a valid argument because the information in the conclusion is not contained in the premises. Now that can be useful. They can be good inductive arguments and bad inductive arguments. But we're just interested in valid arguments, in valid deductive arguments. And in valid deductive arguments, you never state any information that is not contained in the premises. Okay? All right, bless you. So, if a term is distributed in the conclusion, it has to be distributed in the premise. Does this pass rule number 2? Some SRP is the conclusion. Why does it pass rule number 2? Because neither of these are distributed. So it just says if they're distributed, then you have to start looking at the premises. You don't even have to look at the premises because it's not distributed. So it passes rule number 2. Suppose this was, and actually that's a good thing. Why is that a good thing? Because neither of these terms is distributed in the premises. Why isn't this distributed? Why isn't P distributed here? Because this is affirmative. The predicate is distributed when it's negative. And this is affirmative. And this is, and S is the predicate of this one. So neither P nor S is distributed in the premises. But it's okay because they're not distributed in the conclusion. Alright, so it passes rule number 2. Does everyone see that? Yeah? Alright, number 3. The premises cannot both be negative. Why not? Well, because, again, it's a bit like this. You're not really giving positive information. You're saying what things aren't. You need to give positive information before you can establish a link. Does it pass rule number 3? Yes or no?
Yes.
Yes, in fact, both premises are affirmative. They can't both be negative. You can have one negative, but you can't have both. Well, they're both affirmative, so it passes it. Looking good for IA-I3. Just one last hurdle. If one premise is negative, the conclusion must be negative. And if the conclusion is negative, one premise must be negative. Does it pass that rule?
Yes.
Yes, because the conclusion is not negative. You can sort of combine rules 3 and 4 to say this. The only combinations allowed are either all 3 are affirmative, or one premise is affirmative, and the others are negative. So either you have affirmative, 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 or you have a negative conclusion, a negative premise, and one affirmative premise. Those are the allowed combinations. Okay? So what have we just shown? Yes. So in other words, if it's true, what was that one? That was any good poem is worth reading. If it's true that any good poem is worth reading, and it's true that some good poems are difficult, then some things worth reading are difficult. That's valid. That's a valid argument. If the premise is true, it guarantees the conclusion. Okay? All right, let's try some more. Actually, look on page 257. Let's just do some fast testing of validity. Randy, don't forget your little post-its. They're on the floor there. Otherwise, I'll steal one, because those are cool. All right. So practice quiz 9.6. It says use Venn diagrams, and you don't know how to do that yet. You will. But for now, we're going to use the rules. Okay. Now, Charbel. Yes. What is the first rule without looking it up? No. The first rule is to do with distribution. If what is distributed? No. The first rule is about distribution of which term? The middle term. What has to be true about the middle term? It must be distributed in at least one of the premises. All right. Let's look at number 1 on 9.6. Is it distributed in the first premise? How do you know?
Because null is universal.
No is universal, and M is the subject. So M is the subject of a universal, so it's distributed. Do we care about the other premise? No, because if it's all we care is that it's distributed at least once, and it is. All right, so passes rule number 2. I'm sorry, rule number 1. Nick, without looking it up, what's rule number 2?
If it's distributed in the conclusion, it has to be in the same one in one of the premises.
It has to be distributed in one of the premises. All right. Does this pass rule number 2?
Yes.
How do you know?
Because it's not distributed.
Because neither S nor P is distributed in the conclusion. So, rule number 1 asks us about the distribution of M. Rule number 2 asks us about the distribution of the other two terms, S and P. Incidentally, there are names for types of arguments that fail rules 1 and 2. If you fail rule number 1, that's what the X means, this is called committing a particular kind of fallacy. That's right. A fallacy is a failed argument. Now, usually, this means that the argument is invalid. In the vast majority of cases, the way an argument fails that we care about is by being invalid. And in this case, if you fail rule number 1, you're obviously invalid, and it's called the fallacy of undistributed middle, which is not a very snazzy name, but at least it's informative. Why is it a fallacy? Because the middle term is not distributed. Undistributed middle. So, for example, we saw that anything that begins I is going to commit this fallacy. Now, this is kind of a tangent, but it's worth saying. There are some fallacies that are valid arguments. And the most famous of these is begging the question, which I've already ranted about because people misuse the term. People say begging the question when they mean raising the question. Actually, begging the question has nothing to do with questions. It has to do with arguments. And you commit the fallacy of begging the question when you claim to prove something, but the way your argument that claims to prove it assumes it as a premise. Now, why is that a valid argument? Because it looks something like this. Your conclusion is P, and your premise is also P. Is that a valid argument? It's about as valid as they get. Because what's the test for validity? Imagine that the premise is true. Would that guarantee the conclusion? Duh! They're one and the same. Okay, so that's a valid argument. Well, why is it a bad argument? Well, it's a bad argument because the point of an argument is to prove a controversial claim. Well, to prove a controversial claim, you shouldn't assume the controversial claim because nobody's going to believe you. right? It's like me saying, I'm going to prove to you that Elvis is alive. Here's my premise. Elvis is not dead. If you allow me that premise, I can prove that he's alive. You're not going to allow me that premise. Sometimes they're less obvious, but actually what is called circular reasoning is an instance of this fallacy. A famous case is something like this. Imagine, if you will, you are a skeptical atheist, and I'm going to try and convince you. Let's say I'm going to use Christianity. I say, I want you to convince you in the truth of the Christian God. And you say, I don't believe it. And I say, but it says God exists in the Bible. There. And at this point you say what?
So what?
Why should I believe the Bible, you say? And I say, the Bible is the Word of God. What's the problem?
You don't believe in God in the first place.
Yes, I'm using each to support the other. So I'm saying, I'm going to prove to you that God exists by saying that it relies on, but my argument that God exists relies on the existence of God. Because it relies on the Bible being true, and my evidence for the Bible being true is that God exists. Okay, so I have begged the question in that case. All right. Back to fallacies. Okay, so this admits the fallacy of the undistributed method. Now, there are two ways that you could fail rule number 2, because rule number 2 covers 2 terms. If you fail it by having the subject distributed in the conclusion, but not in the... So, for example, suppose we had this. All S are P. Is S distributed in the conclusion?
Yep.
Everyone?
Yes.
Yes, because
Universal.
it's universal, subject of universal. Is S distributed in the minor premise?
No.
No, because it's...
Particular.
No, it's not particular.
Affirmative.
Because S is the predicate of an affirmative. When it's the predicate, you care about whether it's affirmative or negative, right? So S here is the predicate, right? Here becomes that. Okay, so this would fail rule number 2 because of S. Something that fails rule number 2 because of S is called illicit minor. Guess what something that fails rule number 2 because of P is called?
Illicit major.
Illicit major, yes. Sounds like a military offense. There you go. So those are the names of the 3 fallacies. Now it turns out there are no names for when you fail rules 3 and 4. People got bored at that point and didn't come up with names. But those are the names of the fallacies. How far did we get? We got, it passed rule number 1 because M is distributed in the first premise. It passed rule number 2 because neither term is distributed in the conclusion. What about what about rule number 3? Does it pass or fail? What is rule number 3? Without looking?
So
The first 2 rules are about distribution. The second 2 rules are about negativity.
yeah, they cannot be both negative.
What can't both be negative?
The 2 premises.
Right. Does it fail that rule?
Certainly.
Yes, because the first one is negative universal and the second one is negative particular. So it fails rule number 3, so it's invalid. And at that point you can stop. But we might as well work out what is rule number 4.
If one premise is negative, the conclusion must be negative.
And vice versa, if the conclusion is negative, then the premise. Well, it also fails that one, because the conclusion is affirmative. So it fails rules 3 and 4. Bad arguments. All right, let's briefly burn through the second one. Zach, what's rule number 1 again? To do with distribution? That's right. Zach, Brian. All right. My system is not infallible. Okay.
The middle
Brian.
term needs to be distributed.
The middle term needs to be distributed.
Which it does in the second premise.
And also the first premise.
Yeah, first premise.
In both cases because?
They are universal.
Yes, in both cases they're the subject of universal. We're looking at number 2. All right, so rule number 1. Brian, that's right. Destin, what's rule number 2? term is distributed in the you're getting quieter as you're getting less sure of yourself. Help her out. What's the next word? If the term is distributed in the conclusion, then it must be
Distributed in the premise in which it occurred.
okay. Is P distributed in the conclusion? Yes or no? What's the rule for predicates? They're distributed when the categorical proposition is negative. Is this one negative? No. So P is not distributed, so we don't care about it. Is S distributed?
Yes.
Why?
It's universal.
Because it's universal. So we have to check. Is S distributed in the minor premise? No. Why not?
It's not negative.
Because S is the predicate of an affirmative. So what fallacy does argument number 2 commit?
Undistributed middle.
Not undistributed middle. Illicit minor. Illicit minor. Okay? Sounds like underage drinking. Alright. Do we get it? Are we happy? Are we ready to take our homework, the next homework? Well, not yet, because I haven't explained about Enthymemes. Yeah, I was expecting you to say that, but it's kind of a mouthful. Enthymemes. What is an enthymeme? No doubt you throw the word around at dinner parties. You don't go to dinner parties. But if you did, you'd throw around the word enthymeme. What is an enthymeme? Well, as is often the case in logic, it is a fancy word for something fairly straightforward. It is, I will write the definition, a syllogism, an enthymeme, is a syllogism with one of the propositions missing. So how many propositions are there in an enthymeme?
One that's visible, there's still two.
There's two. Yeah, when you're given an enthymeme, you're given two propositions. Right? Because a syllogism has three, and in an enthymeme, there's one missing. Why do we care about such obscure things? Well, when we talked about missing premises, it turns out that often premises are missing because people don't bother to state all of them. Now, I've said propositions are missing because sometimes people don't even bother to state the conclusion. Like, for example, if with the Chihuahua argument, if I said, all Chihuahuas are dogs and all dogs are mammals, so, and I just left it up to you to come up with a conclusion. I would have given you an enthymeme. I would have just given you two propositions and you could work out the missing one. That quite often happens. So what we need to be good at is working out what it is that's missing. Let's look at number 3 on page 243. It's got a rather old-fashioned spelling for Muslim. It used to be a more common spelling, Muslim. Number 3 on page 243. Here is the enthymeme. Some Europeans are Muslims, since some Cypriots are. What is a Cypriot?
Person from Cyprus.
A person from a citizen of Cyprus. I won't ask you what Cyprus is, I hope you know. All right. Now, do we have the conclusion in that case? What is the conclusion?
Some Europeans are Muslims.
Some Europeans are Muslims. What type is that? A, E, I, or O? I. So it's some S, R, P. So S is Europeans, Euros. P is Muslims. I'm going to spell it a more contemporary spelling. And M is Cypriots, because it's the one that's not stated in the conclusion. All right. Now, we're only given one premise. Which premise is it? Well, first of all, the premise is some Cypriots are. Are what?
Are Muslims.
not European. Muslims. So given that, so the premise we're given is some Cypriots are Muslims. Which premise is that? Major or minor? Yes, it's one of those two. Which is it?
Because Muslims are pathetic.
Yes, it's major because it contains the major term, which is why it's important to know what some Cypriots are. The implication is that they're Muslims, not Europeans. So, I would write it here. Some M, because it's some Cypriots, are Muslims. So, what is the implied missing premise? Well, what two terms will it contain?
Europeans and Cypriots.
Europeans and Cypriots. What do you think is the most obvious missing premise?
All Cypriots are European.
All. Obviously, it wouldn't be all S or M. What would that say?
All Europeans are Cypriots.
Right, which would be very hard to cram onto that island.
Don't tell the French.
Right. Don't tell the French anything. They just won't listen. So all Cypriots, all M are S. And when you fill that in, it should be a valid argument. We can test it for validity very quickly, but that's an example of an enthymeme, and you discover, first of all, you can work out which premise it is that's missing by working out what premise you've got. If it's got P in it, it's going to be the major premise. If it's got S in it, it's going to be the minor premise, and you have to find the other one. And in this case, the obvious one. And why isn't this stated? Because it's common knowledge. All Cypriots, you knew that. All Cypriots are Europeans. If you were asked, you could probably work it out. All right, so what is the condensed form of this?
Don't you have
A.
I, 3.
Aren't your premises wrong though?
They switched the major and minor.
My God, you're right. I was just doing that to test you. Yes, very good. That was a catastrophic mistake, and it's actually I3, which of course we've already tested, and we know that it's valid. So all, what was it? All M are S. All educational. I just, yeah, good thing you picked up on that. I would have had to tell you otherwise. Good. Don't make that mistake of putting them in the wrong order, because otherwise you get the wrong condensed form, like that. A learning moment.